Alright, so we got to deal with this fact that there are rather strangely distributed observations. This is a couple days of observations that came in on a different network. And again, you can see, well, some places are really well observed, other places not so much. But that's the best you can do, because we're not going to build a whole bunch of ships loose. Cool. So, seems like we need a better system than that. So, another good option would be to observe the sea surface temperature from space, using remote sensing. You all clear about the difference between remote sensing? Oh, that means that we have 5 minutes left. Should I snooze or stop? I should stop. Remote sensing versus in situ observation. Okay, we're clear on the difference here. Remote sensing is all about the instrument is not touching what it's measuring the radiation that's being emitted by the object. Whereas in situ is like the buoys and the ships, right? They're actually touching what they're measuring. Sea surface temperature happens to be one of the easiest things to measure from satellite. Now that doesn't mean it's easy, but it's one of the easiest. We can, from satellite, as we'll see, determine things like air temperature and winds and stuff like that, but from the point of view of what's easy and what's hard, sea surface temperature is about as easy as it gets because the water is made of something we know. It's made of water. And water we can take in the lab and we can study how it emits at different temperatures, and then we can make a satellite that will use, remember by Stephan-Boltzmann's law, the temperature increases, the amount of radiation it emits increases. We can study the water, we can figure out exactly at this temperature it's going to emit this much radiation, and we just build a satellite that goes and observes it. It works. Got problems if there's clouds, it's got problems if there's dust, but overall it works. And in fact, you see this all the time. You get on the internet and look for sea surface temperature, and you'll get all these lovely maps like this, which are sea surface temperatures observed by satellite. And you can see it's got a really high resolution. Here's New York and New Jersey, here's Philadelphia, here's the Delmarva Peninsula, so this is pretty high resolution stuff. And like you can see here, it's the Gulf Stream, and you can see eddies, and these are only a few kilometers across. You can see it's got problems with this cloud, by the way. The clouds are also made of water, so it's kind of hard on these clouds in the air, from the water rather. But this works, and it works pretty well. There are calibration issues. Satellites are not perfect. They have calibration problems. Once you launch it up there and throw it into orbit, it's up there forever. There is no way to fix it when it breaks, when it gets out of calibration. So there are elaborate other teams probably across the hall from the people studying the buoys and the ships. There's other people who are figuring out at any given time how much the satellite is out of calibration and what we can do about it. And there are problems with the differences between bulk temperature and skin temperature of the ocean. Let's talk for a second here about bulk versus skin, and that'll be enough for today. Here's the surface of the ocean, and you want to measure the water temperature. If you do it in an in situ sort of way, by sticking a thermometer in it, I don't care if this is on a buoy, on a ship, at an island station, I don't care, you're getting the water temperature down here. This might be inches from the surface, it might be a fraction of an inch from the surface, it might be feet from the surface, but it is not the surface itself, as in sea surface temperature. It is what's known as the bulk temperature. And it's just because there's only so close you can get to the surface with a finite thermometer, right? At some point there's just only so close you can be. On the other hand, a satellite, or another remote sensing application, is measuring the long-wave radiation that's being emitted by the ocean, and then applying Stephan-Boltzmann's law to figure out what the temperature would be in order to add that much radiation. And it is the very, 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 very surface of the ocean that's emitting that radiation. Certainly, there's debate as to exactly how deep we're talking here, but certainly on the order of 1 millimeter or less. What a satellite is seeing is the skin temperature. The very, 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 very surface. These are not generally the same. I have a question for you. Which do you think is generally warmer, the bulk or the skin? Why do you think the skin? Okay, that's a really good guess. It's also wrong, but everybody always guesses that. Skin is colder. I like your answer that the skin is getting more direct radiation from the sun, but keep in mind that that radiation largely penetrates into the ocean. I mean, the top one, how much does the sunlight do that first millimeter stops? Not very much, right? I mean, just, if it was, when you got into the water, it'd be dark, right? To stop with this light. So the skin doesn't absorb that much of the radiation, it's absorbed with depth. And the skin is where all the evaporation happens. And evaporation is a cooling process. So the skin tends to be cooler than the bulk. Now, how much cooler depends on lots of complicated factors associated with how much wind there is, how salty the water is, how stable the ocean is. That is a complicated business, but it is different. Now, there's another whole boring lab at Camp Springs or Silver Springs or wherever the World Weather Building is who figures this out. Okay? It can be done. In the great scheme of things, it's a relatively simple problem. But we do have to keep in mind that if a satellite passes over a ship and the ship is measuring 20 degrees Celsius for the water temperature, that's not what the satellite's going to see. But that doesn't mean the satellite's wrong, it doesn't mean the ship is wrong. Okay, so we've got this business of skin temperature versus bulk temperature. On Monday, we'll talk about what do we do then? When we get a map of sea surface temperature like the ones you saw in Volume 2, what is that? Is that skin? Is that bulk? And then we're going to talk about sea surface temperature. We'll look at some maps of sea surface temperature, talk about the features of water temperature in the tropics. Where is it warm? Where is it cold and dry? All right, I will see you guys on Monday. I'll check the reading list to see if I need to send you anything. Hopefully by the end of next week the books will be in and we won't have to worry about that problem anymore. All right, have a good weekend.